Na 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 na. Da da na 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 na. Da 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 da. So let's talk about actually calculating the normal probabilities. We have the Hulk, not me. It's easy to get us confused. The probability for going a certain number of days follows the normal distribution days. Yeah, 20 days, so a little less than a month. And 4 as our standard deviation. I hope when you see this, your mind instantly does this. At some point, I may stop drawing the picture every single time, but your mind should be drawing the picture. Our mean right here is 20, and our standard deviation is 4. So let's address the question, what's the probability the Hulk goes longer than 26 days? Well, I can draw that. Where is 26? If we were in class, I'd do this, and you'd tell me when to stop. And hopefully what you would see is this is 4, so 24 lands right there. 28 is right here. 26 must be right there. So what's the probability the Hulk makes it more than 26 days? You would find this area right there. We can kind of eyeball that, 5, 10. Let's see if we can get it exactly. In order to get it exactly, I need to tell the computer exactly where I stopped. I don't want to tell the computer 20 and 4 and have to change that every single time. So instead what I'm going to do is I'm going to tell the computer how many standard deviations I had to go. Was it 1 standard deviation? No, that's not enough. 2 standard deviations? No, that's too much. Exactly how many standard deviations? In your head, I'm sure you've already done the math. Let's pretend you can't do it in your head, and let's go through it slowly. What you would do is you would take 26 minus 20. In other words, how far away are these guys? And the answer is they are 6 units away. And how many standard deviations is that? Well, 6 units away out of 4 for our standard deviation gives us 1.5. This calculation we're going to do so much, we're going to give him a very short name. His name is Z. That is the z-score equation. And this is a z-score. Z-score says, how many standard deviations away am I? Well, I'm 1.5 standard deviations up there. Now let's go to the applet. When you do the homework, there's going to be a link that takes you to this applet here. Now, these buttons are for different distributions. We will talk about them later in class. Right now, we are doing the z distribution, which is the standard normal, so this is what we want. Notice what do we have right in the middle? 0, because you are 0 standard deviations away from that mean. Here's 1 standard deviation away, 2 standard deviations away. I can actually drag this up to, what do I want? I want 1.5. I can't get it exactly, I'm just typing in 1.5. 1.5 standard deviations gives me a probability of 93%. Let's look at our picture. Does 93% look like the answer here? Well, no, but this isn't what the applet looked like either. It was going from here all the way to the left. I want from here to the right. So there's 2 ways I could do it. I could take this probability and take 1 minus it, which would give me, what's about 7%? Or I can just click flip sides. Looky there. There is our answer. 0.06681. 0.06681. What's the probability that the Hulk can make it more than 26 days? Well, it's about a 6% chance. Let's write the question differently like this. What's the probability the Hulk makes it less than 11 days? Well, this is a different picture. I need to find where 11 is on here. I know this is 4, so 16 is right here. 12 is right there. 8 is down here. So 8 and 12, 11 is somewhere right in that range. Really, really small chance. So there is the area that I am looking for. Now I need to know exactly how many standard deviations. It's just slightly more than 2, but I need to know the math. I'm going to follow the same thing I did up here. Z equals, this is 11, so I want to do 11 minus 20 divided by 4 as my standard deviation. And the answer, if I do that in my head, is, let's see, carry this out and be negative 2.25. Now, as a completely unrelated note, if you happen to be putting this in your calculator needs the 11 minus 20 to be in parentheses, so that becomes the entire numerator. If you don't get those parentheses right, you'll get the wrong answer. Notice we've got a negative value. Is that okay? The answer is yes. Negative means we are below the mean. So getting negative z-scores is fine. It just means you're less than what you would expect. And indeed we are. We are way less than. Let's see what the applet says. We're going to change that 1.5 into a negative 2.25. And I do need to flip sides again. The answer is 0.01222. Let's formalize exactly what we did with that z-score. Z was, we took the x value, which is the number that we were interested in, and we subtracted that from mu, the mean. And then we divided that by the sigma. That's an equation you're going to get to know lots and lots in this class. You might as well just memorize it right now. X minus mu over sigma. The idea is to take what you've got, subtract what you expected to get, and divide by a measure of the error. And lots of statistics is summarized just by this statement right here. How far away are we from what we expected relative to the error? That's a z-score.